Good evening, everyone. My name is Gozdzicki. I'm representing Dutch company, SuperB, where I'm responsible for business and product development of the lithium-ion batteries. So both our host and Tomislav mentioned that electrifying of the vessels, it's not an easy thing to do, and it's definitely a future. Yes, that's right. This year, if we calculate the number of electrical vessels in Europe, being both in service and being both under manufacturing, it's about 210 vessels, the big vessels, and according to the NVGL, number one country for that so far is Norway. They have in service around a little bit over 80 electrical or hybrid vessels, and rest of the Europe remain with 130. Next year and following years, there are expected that there will be built around 100 electrical vessels on lithium-ion batteries. But those are the bigger vessels we are supporting. Tomislav, on the boat that you saw, we also do a lot of other projects. Now, in general, when we are talking about electrifying ship, boat or vessel, we very often mean different thing. But in reality, this is a very complicated operation. And the number one thing that is extremely important is the system integration. As you can see, building a lithium battery vessel means that you have to consider the size of power bank, what kind of the propulsion, what kind of chargers, would it be an onboard or the shore chargers, what kind of inverters, what kind of monitoring system. Tomislav showed you how ICAT is using remote monitoring system, so actually every minute you can check what is going on with your boat. And last but not least, the most important thing overall is safety. Nobody wants to have a problem with a vessel on the water. There's an example of another boat that we are also doing with our friend Branimir from company Tema from Pula. You can see an example of the electrical scheme. It's quite complicated thing, and really a lot depends on the success of that project if you have experienced system integrator. When you build that kind of vessel, and I would like to tell that there might be different kind of vessels, so it could be either with a power bank that supplies propulsion, or could be a hybrid system, or could be a hybrid system not necessarily connected to propulsion, maybe supporting some pumps or some, we call it hotel batteries, so some electrical devices on the ship. There are different things, but definitely those are the risks that you can meet during the concept stage or design of the electrical vessels. And those are design errors, those are the interferences on electromagnetic compliance, those are communication breakouts between those systems. All the systems are communicating with itself, and as a result you can see the information that you get on monitoring system. All those situations can lead to the state of uncontrol that we are all worried about when it comes to ships with lithium-ion batteries. We do our best to keep the batteries very safe. We do a lot of protection. I will tell in a minute about it, but there's always possibility that battery will get in a state of thermal runaway, and then when the problem starts. Before I would go and explain what can be done against the thermal runaway and what it really means and how it starts, I'm not sure about your knowledge about the batteries. So if you look at differences in lithium-ion batteries, there are a few kinds. maybe more than few, but just a few of them are in commercial use. So they could be different on the anode material. Most likely you will see graphite, but sometimes there's some small addition of lithium titanite. And the material on a cathode, which is either lithium manganese, lithium cobalt oxygen. Those are the most common types of anode materials for mobile phones, so any iPhone would have it. Then you have NMC type of batteries, which is nickel, manganese, cobalt, and that kind of batteries you most likely would find in cars, like Tesla or BMW, and also in many power tools laptops. And similar NCA that just depends on the manufacturer. And then we have lithium ferrum phosphate type of battery. If it comes to the physical structure, we can identify both cylindrical and prismatic battery. Why do I mention this? It's because each of those batteries represent different safety concerns. It represents different energy densities, and wherever we are thinking about what kind of battery we want to use a certain application, we are looking at all those possibilities. So here's a comparison of different types of batteries. Of course, they vary, but one of the most important things is volumic energy density. Maybe it's a little easy to say, but the more energy, the more, of course, battery is danger. So let me now come back to the main concern, main risk that could be caused by batteries, which is thermal runaway. How do we protect this to happen? So as everybody knows, battery is made out of cells, and the first protection is on the cell level. So there are some vents in case the battery gets heat up, the fume starts building, and the vent is destroyed, and the battery is destroyed, so it's not working anymore. There are some batteries like prismatic with electrical fuse, and of course important part of the protection is housing. On the battery level, we add electronic devices like battery management systems, whose role is to protect from under voltage, over voltage, discharge, high temperature. That electric device should switch off the battery. Then important is housing, then important is the quality of internal connectors between cells. And some batteries require additional either passive or active cooling. Additional protection for batteries are necessary certificates. In general, the industry is relatively new. So you can't see a lot of battery standards that would be accepted by all manufacturers, but there is one, which is called UN 38.3 certificate. This is necessary for shipment of the battery. So if you want to ship batteries, if you do not have this certificate, no professional shipping company will accept your battery. And in order to pass those tests, to get this test, those are the tests that each battery, sometimes cells, needs to pass. Just to give you an indication, vibration test means that battery is put on a bench, and with 50 G movement, it cannot fall apart the inside connectors. So in general, we can consider if battery has the certification, it should be safe. Now, I was talking before a little bit about different materials on a cathode and thermal runaway. So what is exactly this thermal runaway? If the temperature of the cell reaches certain value, then it starts heating up and it cannot stop until it's burned down. Different kind of batteries, depending on the material on a cathode, would start the thermal runaway at different temperatures. So The battery that you have in your phone would start at around 150 degrees, whereas batteries that Tomislav is using on his vessel would start at 195. Another important value here is the maximum temperature that has been reached, so it's 800 degrees versus 400. And the gas emission, also very high on that. So that's, sometimes you hear about stories about people that had burned on their lab when they had some problem with battery. When we consider all the things like safety, like ability of the certain battery type to give or take certain currents, then we can actually make a decision what kind of battery you would like to use. Those are the most typical things that we should look at the choice of battery chemistry type. So space availability, different batteries would have different energy density. Sometimes there's not enough space, so you have to look at the battery that is dense. Current profiles. Not each and every type of chemistry allows you to take high currents. That's not always needed. Charging time, again, not every battery will allow you to be charged fast. There are some limitations. Another one is lifetime expectancy, so perhaps in theory some batteries could work 40 years. Definitely they can do a lot of number of cycles, up to 5,000 or even more depending on the usage of profile. I mentioned before that also important is to look on different types of battery applications. So we are not only choosing battery looking at all those features that I mentioned before, but we also need to understand if the battery needs to serve as a main source of power, as an additional source of power for propulsion, or is it only used for miscellaneous services that maybe or not necessarily could be connected with propulsion. After getting all that, we should be a little step closer to make decision which battery is good for what. So some examples of fully electrical vessels. Our company has electrified already 60 trams in Amsterdam canals. We also helped build Tomislav's iCat. In general, fully electric vessels are very well for predicted routes and predicted loads, because then we can build the right battery bank. There are many hybrid systems, so batteries could be used as additional booster for bow thrusters, as a peak shaver, for maneuvering, or could be main propulsion in areas where there will be definitely restricted pollution acceptance. And as a service battery, which are independent from propulsion, could be good alternative for idling engines, would allow to take higher amps intake, and that could result with a huge fuel saving on a bigger boats. So after all this, considering all the features, all the requirements, you can build good energy bank that is understood as X-series, X-parallel system that delivers the required volts, currents, that is built within given space, with necessary safety applications, and with good communication with external device. That would be it. Thank you.
Questions? You didn't talk much about battery management software, and I think this is a crucial component of all these requirements.
Yes, it's one of the very important requirements. Again, it depends on the full system. What we see on the vessels that each one is different, and many of them would have different requirements. So there is a tendency to have different BMS systems, either dealing with that problem or that problem. Unfortunately, developing of BMS is a very time and cost-consuming process. So there is tendency from the customer to have customized BMS and manufacturer to get universal BMS.
Questions?
I do have some questions. So I have seen in your presentation a lot of specific problems to be solved, of course, and some of them were solved to some degree satisfaction, and some maybe offer more space for some collaboration in research and development departments.
Yes, as Super B, we are located in the area of where we have very good University of Twente, and we had quite close cooperation with that university. We do a lot experiments with them on existing batteries. So we check how the battery are acting. We do the cycling. We do lots of different experiments that help us to build safe battery system.
Thank you.
Any more questions? Where?
Goran Krajic, University of Zagreb. I have a question regarding the recycling of the batteries.
Okay.
How is it done, and how, in which percentage we can recycle materials, etc. Because this is
Okay, so
important.
so far it's a tricky thing. First of all, the batteries are expected to live long. For the purpose of moving from point A to point B, over the time batteries are losing its capacity. For example, the type of batteries that we are using, after 5,000 cycles, it is supposed to have 80% of initial capacity. That means that for purpose of travel, it may be not enough. But this battery is still good, so and it still has a value and could be used as a power bank for example, as a solar bank. So we are expecting a battery to live about 20 years. If it comes to recycling in terms of getting the components, according to my knowledge, right now it takes more energy to get the materials back than so it's just not profitable enough yet. So that's the problem.
And are you aware of any EU regulation that allows to use the batteries from vehicles or vessels in stationary purposes, or they should be recycled?
Well, as long as these batteries are safe and as long as they have a history, and majority of them is equipped with monitoring system, that is safe. I do not know any regulations, but definitely a lot of second-hand batteries are used for energy storage, which does not require any movement.